Hello, I'm Shubhendu, and in this session I will be discussing about the NetConf protocol support, specifically the NetConf client emulation support that has been introduced newly in IxNetwork. Since this is a new protocol getting introduced in IxNetwork, I will give a brief overview about the protocol, followed by some use case scenarios that can be addressed by the NetConf client emulation, and then a live demo will be presented using the IxNetwork GUI. So as you may know, network configuration protocol, better known as NetConf, gives access to the native capabilities of a device within a network, defining methods to manipulate its configuration database, retrieve operational data, and invoke specific operations. Whereas EANG provides the means to define the content carried via NetConf for both data and operations. So together they help users build network management applications that meet the needs of network operators. The motivation behind NetConf and EANG was, instead of individual devices with functionalities, to have a network management system that manages the network at the service level. That includes standardized data model, network-wide configuration transactions, validation and rollback configuration, and centralized backup and restore configuration. So these are some additional benefits that are, to name a few, that network configuration managers can have from the NetConf protocol. So now coming back to this, the figure that we have here on the left, this left hand side, NetConf client server model. So this is basically NetConf is a client server model, where on the right hand side it's a networking device, maybe a switch or a router, and in the left hand side there is a NetConf client or controller which controls the configuration of the network nodes, and it can either set the configuration or get the configuration from the network nodes that is on the right side, which is also called NetConf servers. The NetConf protocol runs over TLS or SSH. We are supporting SSH. Over this SSH session, the client sends RPCs or remote procedural calls and notifications that the NetConf client uses to manage the configuration of the NetConf server nodes. This in turn uses some methods like edit config, get config, lock, unlock, etc., through which the data at the server is accessed, where the data is well defined and is either configuration data or protocol states and various statistics which can be accessed by the client. On the server side, there may be different protocols configured, and different layer 2, layer 3 protocols, and their data structure along with their state and statistics. On both client and server, the yellow colored portion that you can see, that is actually defined by the EANG data model. So these configuration parameters, statistics, protocol states are defined in EANG data model. There are multiple EANG data models available like IETF, OpenConf, and even there are some vendor specific EANG modules as well, customized EANG module as well. So now let's see, concentrate on the test topology that we'll be discussing over here, to show how Ixia's IxNetwork NetConf client emulation can be used to test a NetConf server or a system of NetConf servers. So these green color, boxes, these are basically multiple NetConf clients which are connected to a single NetConf server, which is the device under test. So and these green boxes, there are multiple NetConf clients. These are actually emulated by the IxNetwork's NetConf client emulation. So you can see that the number of NetConf clients, you can configure multiple number of NetConf clients, and this red encircled portion, this is called a device multiplier. By controlling this multiplier, you can actually configure multiple number of NetConf clients as per the test need. Now in the subsequent slides, we'll be discussing about some use cases, some use case scenarios by which the NetConf client emulation can be used to test the NetConf server. So here the first one is about the SSH and NetConf compliance of the duty. And some points are like test duty's capability to handle different types of SSH login mechanisms, which we support, like username password based or key based. Then there are these configurable SSH port, either 22 or 830, or you can have customized SSH port as well. Then there are some NetConf capability negotiation. We support multiple capabilities. You can just on off those capabilities based in the configuration page based on your test need. And there is this very important enhancement that we have done on the Wireshark. So what happens, NetConf is basically SSH encapsulated, so packets are encrypted. So you can see this encrypted SSH packet. If you just capture a NetConf session packets using Wireshark, you will see that the data portion is totally encrypted, so you cannot make out what's going on there. You cannot see the procedural calls, the XMLs that is getting exchanged between NetConf client and server. So we have come up with a decrypted decrypted packet capture solution, by which you can actually decrypt these SSH data and show them what actual data has been exchanged between the client and the server. You can see on the decrypted SSH packet on this right hand side box, you can see that actual RPC replies, that this was the RPC reply that was actually encrypted in this data form. So this is a very important and useful feature of this NetConf client emulation, and this is you will be very useful if someone wants to debug what's going on between NetConf server and client by capturing the packets. Next, how well the duty handles concurrent client connections. So here you can see that there are multiple clients talking to the same NetConf server. So the purpose of this test case is to see that how well the NetConf server talk with multiple NetConf clients at a time. So maybe the different NetConf clients are doing different operations to the server, like some may be writing some commands, some may be asking for some commands. So how does duty perform in such a scenario? Maybe multiple controllers accessing the same duty config database simultaneously, multiple controllers doing different actions simultaneously. Test duty's capability to handle multiple concurrent NetConf controller connections. So how does the NetConf server behave or perform when there are multiple NetConf clients talking to him concurrently and asking for different types of operations at the same time? Next is how well the duty handles command snippets in random order in bulk. So as per NetConf, the any configuration is basically atomic, so it is basically called transactions, not configurations. Each transaction consists of multiple configurations commands, and within a transaction this the order of the configuration commands doesn't matter. So you can actually test whether a duty that is a NetConf server can take transaction which consists of commands organized in random order. So duty's capability to handle command snippets in random order, then test's capability to handle commands in bulk. So you can send multiple thousands of commands from the client in the form of XML request messages and see how the duty is responding to that. We support different kind of transmission behavior. There are control over that. You can send some continuous request messages over a configurable frequency, or you just want to send some once or twice, or you can control the transmission behavior of the NetConf client. Then stress the duty by sending commands for long duration repetitively. And this is one more very important stuff, is bring your own young data model. So our client emulation is agnostic about the young data model that your server is supporting. So whatever the young model the server supports, we just take the XMLs as an input, and the XMLs has to be written in the format that the duty supports the young data model. As per that format, if the XML is written, we just take the input the XMLs as an input and send it over the NetConf session, and then it's up to the duty how it responds to that. So our NetConf client emulation is totally agnostic to the young data model, and we can work with interop with any young data model that is available in the market. The next one is to measure the response time of a transaction of the duty. So how quickly the duty can respond to netconf commands. Measure time taken by duty to respond to netconf commands, and this can be done in multiple levels. So just to briefly talk about what is this response time, how we are measuring it. You can see this block diagram, time block diagram. So the left hand side is the netconf client, the green one, and the right hand side is netconf server duty. So we are sending a request sent at a timestamp t1 that is received at the duty by t2, and then he replied that sends the response of that request at t3, and that response has received at the IxNetwork side at t4. So the response time for this first request is basically t4 minus t1, and you can send multiple such command snippets in the form of XML and measure the response. So you can see that although these request messages were sent equal time apart, but the responses are not equally distributed in the time. So the duty has taken some more time for the third command snippet than the first one. So these response time we offer in different levels. We measure this response time. Response time can be measured on over the port, meaning the port over which the client is connected to the duty. So overall the duty's response time on a port. Then we can have min-max average response time per session, meaning how if there are 10 clients talking to the duty, we can find out that for each client session what is the response time of the duty. Then drill down further on each session to get min-max average response time for each command snippet of a particular netconf session. Get the absolute response times of the last snippet sent out on a session. Response time for each reply XML is also recorded in the reply XML. So these are very useful features that we are offering, using which the duty's response time can be measured. Verify duty response time under stress. So send commands in bulk periodically, stress the duty's netconf engine, and find out how the duty's performance is going on, and measure the in terms of response time. The last one, whether duty's forwarding throughput gets impacted by stressful netconf session. So this is basically the data plane of the duty, how if it is getting at all getting affected by the stressful control plane. So send data traffic between Ixia ports with duty in between. So here there are two more Ixia ports connected to the netconf server. Let's say BGP is going on here, and BGP traffic is going on between these Ixia nodes, and duty is forwarding that traffic. So from IxNetwork netconf client, keep sending large amount of netconf data in bulk, keep fetching BGP routing table TXRS statistics from the duty, verify whether duty's throughput gets impacted when the netconf session is under stress. So when netconf is not running, find out the latency of the duty to forward this BGP traffic, and then stress this netconf session and find out how is the latency, the forwarding throughput gets affected by a stressful netconf control plane. So this is I'm not going through the each points of this slide. So this is basically different tips how to do when you are doing a testing, how the debugging can be done using different knobs here and there that are offered in the client emulation. I will be specifically talking about the one particular feature that on the next slide I will be talking about in detail, which is recording client server interactions for post processing. So we records every interaction, every request reply XML messages that are getting exchanged between the client and the server. So every command and corresponding replies are stored, and reply XML's errors stored and organized in a hierarchical order. Response time for each reply is also calculated. So as I said, the reply XMLs are also stored. So if we open the reply XML, the response time is shown there also in the XML file. So you calculate and show it there. So now I will go to the next slide, where the debug directory organization. So we have a debugging directory where if it's a controllable field in the GUI. If you want to store the files, you can always do that. Otherwise you can also make that the feature off, that you don't want to store any files, so that is controllable. So it's well defined directory structure per client debug folder. So there are two clients in this particular test. the example that I am citing here. So per client there will be a debug folder. So there is a parent debug folder which is named as NetConf debug files. Under there will be per client one folder. Then for each within each client there will be multiple runs. If you are having multiple runs on the client, runs meaning one start stop sequence is a run. So if you have multiple runs, so for each run there will be a folder. Then within each run there will be a capture folder and a server replies. So captures, as I said, the decrypted captures, those will be saved over here, and what replies have we got from the server. And further on the server replies, we inside this server reply folder there are the reply messages, actual XML reply messages that have come from the server, and also we show there is a directory for errors if we have received any error from the server. So this is a very well defined debug directory organization, and will be very useful for post processing analysis for after doing the test, if the your tester is interested in doing that. So now we will be going to the next phase, which is a live demo, and we'll be giving this demo using our IxNetwork NetConf client emulation software. Okay, so let's start the demo with IxNetwork's solution, the GUI that we have for NetConf client, the real solution. So here we have two ports back-to-back connected. So by the way, we have a server solution as well. This is a lightweight server solution. I'm not going into details of this. We don't have much feature in the server, but in subsequent releases we'll be adding more features in the server. Right now the server is only capable in a scale in scaling the sessions. So let's focus on the client side. So here this topology one is basically controller. So we have two NetConf clients over here. So I said that this in the previous discussion I said that you can change this device multiplier to increase the number of NetConf clients, or you can also have different devices for the NetConf clients. So let's see how it is. So in NetConf client, if I go to the NetConf client, so here you have to give the server IP addresses and this command snippets, meaning how many command snippets XMLs that you want to send to the customer, I mean send to the user, the duty, the device under test, the server. And so this command snippets, this is a global number, meaning if there had been 5 sessions here, right now there is single NetConf client here. If there were 5 clients, this number would have been common for all the 5 sessions. So if the use case is like this, that in one client you want to send 2 command snippets and in another client you want to send 10 command snippets, in that case this type of topology will be helpful, and that's why we have kept the topology like this. So you can see that on this first NetConf client one, the command snippets, number of command snippets is 2, whereas in the second one we have kept it 6. Okay, so let's see what is there on the command snippet. So before that, on the NetConf client I have these capabilities that I was talking about, so you can play with these capabilities, and there is this SSH thing, the username, password, authentication mechanisms are there. So 3 types of authentication mechanisms are supported based on key. If it is key based, then the key file has to be kept, and this is the directory where you are keeping that directory has to be given as an input. So all these configurations are there, and this is the debug folder that I was talking about, where you define all this debuggability, if whether at all you want this decrypted capture to be enabled or save reply XML to be enabled. If these are enabled, then that this output directory, you have to mention this output directory as well. I have given this as this users admin02 folder where all this information will be stored. By default these are disabled. Okay, so now let's go to the command snippets data. So command snippets data I had given 2, so there are 2 command snippets. So these XMLs, so these XMLs have the RPCs basically inside it. So I can just quickly go, and also the command snippet directory has to be mentioned from where the client will take the XMLs and send those XMLs to the server. This is the periodicity that I was talking about. So periodic continuous, periodic fixed count, once and do not send. So all those different types of control are there. So here the configuration is like periodic fixed count. So every of 2 seconds there will be each transmission one XML file request will be sent out, and after 10 transmission count it will be stopped because it is fixed count. Or you can do continuous, then it will be continuously sent. So if you can just quickly see that in RM resources, so in this folder we have these XMLs. So quickly see what is this XML, how do these XML files look like. So yeah, so this is the XML file, the XML request that is getting sent out. So these XMLs actually have to be written by the provided by the user as per the young data model that the server supports. So this is in a nutshell how the configuration is done, and let's start. What else? Command snippets and transmission control. Yeah, I talked about that. So this is the directory. You can have your own directory. So we have some predefined resources here on this scenario. Here under SDN I have used that in SDN. There is this NetConf NetConf client server. So this can be used as a um, to start with. You can make use of this configuration, and these folders, these XML files are already predefined there. You don't have to write it down. So these are already there to have a basic demo, or basic if you want to play around with the solution. Now let's start the protocols, and we'll see how the statistics and all are there. So NetConf client per port, you can see there are two sessions, there are two clients, so there are two sessions, and this is the yeah NetConf client, and this is the minimum response and maximum response over the port. You can see measured in millisecond, and NetConf PDU TXRX are increasing as we are keep on sending XML messages in every 2 seconds as per the configuration. So all the different types of statistics are available. If someone wants to see the per session statistics, so we can go per session, drill down per session, and see actually per session how is the response time behaving. So you can see this minimum, maximum, and average response time for each session. So as I was talking in the previous discussion. Okay, now I will give you a configuration tips. So as you can see this in this client, so there are 6 command snippets has been added. But if there are more, let's say 10-20 command snippets need to be configured, it's not very useful to give all those inputs here, as you have to key in all those names of the XML files. It's not that usable. There is the option of having these under file. You can actually select CSV, so you can actually have it write down a CSV file, and from that CSV file you can take the inputs, and I'll just show you how a CSV file should be written down for this purpose. So we have to write down a CSV file with the directory name wherever we want to keep the XMLs and the XML names. If we create a CSV file, and then using the CSV file, we actually don't have to write down all these names over here. We can just point to that CSV file. So I have kept go to this file, set the as CSV, browse. So CSV, and so here the directory name. So you get the directory names over here, and then similarly you can get the XMLs as configured written in the CSV file. So we can again point out to this CSV and XML name. So the XML names will be populated. So this is a very useful tips to when you are dealing with multiple number of large number of XML. So this is a very useful way of configuring the XMLs and the corresponding directory. So last but not the least, I will just briefly discuss about the directory structure that I talked about. That's reply XML and duplicate capture this directory. So I'll just go to this directory and show you how this hierarchical structure is there. So here you can see that there are two clients, so corresponding that clients, two directories have been configured. So there are so many runs, 3-4 runs have been given, and you can always get the current text, run text also. This is useful for tickle automation. And if I go inside any run, so there is server reply and capture. The capture files have the pcap files stored, and the server replies have all the server replies that I have got from the server. So since there are no errors received, so that's why there is no error directory. So if someone wants to dig down further, once the test is done, so all the informations are stored here. So that's how. So this is surely going to be very useful for advanced testing. So this is all that I wanted to discuss, and I hope this session will be of helpful to you to understand how the NetConf client emulation software has been designed and how it can be used to test NetConf server in various ways. Thank you.